For the first part of this experiment, we're going to be working on the discharge of a capacitor. So this is the equipment we have for that. We have a multimeter for measuring voltage, because we're going to measure the discharging voltage of the capacitor with time. We also have this extremely high-end example of Swiss horology. So start, stop, reset. But you know, this stopwatch might be hard to see, and realistically most people don't need a stopwatch anymore. So I also have my phone, which I'm just going to unlock, and we're going to use the stopwatch function in this. So let's find that. So you'll be seeing this on the display. We also have this circuit board. So the circuit board is pre-built. We have a start button, which we're going to hold down to charge the capacitor. Now there's an onboard resistor. If you're following along with the circuit diagram in the lab manual, you'll find this resistor marked, but the actual resistor that we want to measure is placed between these two posts. So I can loosen these as they already are. I'm going to put the resistor we choose between those two, and then I'm going to attach my multimeter here across these two metal prongs, and that's going to let me measure the voltage, but we'll come back to that in a minute. Now in the experiment, you get provided with 4 different resistors. We want to identify the 100K one, and I'll show you how to do that with the multimeter, but you also have one of these. And this is the resistor color code chart. So you can see each resistor has bands of color, and you can track them down. You can see to which each color responds. So for example, if we were looking for a 100K resistor, we might want brown, black, black, which would be 100, multiplied by orange, because that's our multiplier line, so you can see the values of that there. I'll insert a photo of this into the video so you can refer to it. But let's just pick a random resistor. It goes red, red, black, brown. So red, red, black, brown. So red, red, black is the first 3 numbers. So it's 2, 2, 0. So 220. And it's times brown, which is 10. So this should be a 2.2 kilo ohm resistor, so 2,200 ohms. Let's cheat. So here's our multimeter. So we're going to connect our multimeter up so that we can measure. Unfortunately, I've lost the cables. So I will be back with you in a second. So here's our multimeter. It's a fairly standard one, but they do vary a bit. Usually, most of the time, you'll want to connect to the common terminal, and then you'll have choices as to what it is you want to measure. In the other, sometimes there'll be 3 of these, so it just depends on the brand and the model. I'm going to measure this, because actually I'm going to measure ohms in this case, and later I'm going to measure voltage. So I'm then going to take my resistor, so this is the resistor that I was just checking the reading of. I'm going to grab my alligator clamps, connect that across there. I'm going to do this in one take so you can tell I'm not cheating. I'm going to turn this around so that it's measuring. You can see in this region it's the ohms region, and probably 20K will do. So this would measure up to 20 kilo ohms, and you can see the reading that we're getting is, let me just move that up, 2.2, so that would be 2.2 kilo ohms, like I said. So this is the resistor I said before was a 100K one. Brown, black, black is 100, which is 100, and orange is 1000. So this is 100 times 1000, so 100,000. But because we're going to do an experiment that takes about 5 minutes with this, we probably just want to confirm that it actually is 100,000. So that's good. You can see there it's actually exceeded the 20K. If I turn it up to 200, there you go. So not a perfect resistor. You can see it's actually 99.8, 99.7, 99.8. But that's well within the tolerance for this type of resistor. You'll find on the color chart There's kind of a tolerance here in accuracy, so you can see if we have this kind of color band, it's 10%. Gold, which I think these are, is 5%, and brown and red are 1 and 2%. So let's have a quick check of that. Yeah, this is brown, so it should be within 1%, but you can see it is actually within 1%, so we're good. Close anyway.